Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 8, Lesson 3, the shifted form of a parabola. You will be able to determine the shift of the quadratic by analyzing the equation in vertex form. Without using your calculator, sketch each of the parabolas shown below on your own set of axes. State the coordinates of the turning point of both. I just want to show you and remind you this from yesterday. This is all review. 2x squared. Well, x squared would be right in the middle, so 2x squared is going to be a little bit more narrow and come up that way. Negative 3x squared is going to be very narrow. And it's going to be, I'm going to just undo that real quick because we have to make sure that we come through the vertex. Should be at the points 0, 0 for both of these. If we have a parabola and the y equals ax squared, then it has a turning point at 0, 0, like both of these do. The only thing that changes is that this is a positive a, so therefore it is a minimum, positive a, and this is a negative a, negative a. So therefore that is a maximum. Exercise number 3 we're going to go to now. Please turn the page over and go to exercise number 3. The exercises are out of order for a reason. The parabola y equals x squared is on the graph shown below. Consider the quadratic functions of yx squared plus 2 and y equals x squared minus 4. I'm going to go ahead and give you the points for both of these in two different colors. I am then going to graph both of them in two different colors, so please stay with me and pay attention. In orange, I'm going to say that y equals x plus 2. I'm going to give you those data points. So it's negative 2, 6, negative 1, 3, 0, 2, 1, 3, 2, 6. In red, or in green, I'm going to give you y equals x squared minus 4. Negative 3, 5, negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, 2, 0, and the last one is 3, 5. Now in orange, I'm going to go ahead and plot those points. I'm going to hit pause, and I want you to plot them as well. Okay, I have all the points plotted. In orange, I have the y equals x squared plus 2. I'm going to go ahead and draw my, I want to make sure that that's in orange. Quadratic. And in green, I'm going to draw my quadratic. There. B. What was the effect of adding a constant to the overall function? So that is what happened in orange. What happened to my orange? Well, hopefully you notice that it went up. It moved up. Now it says C, state the coordinates of the turning point of each of the parabolas you drew. Well, hopefully that you noticed that it was 0, 2. In green, hopefully you noticed that it was 0, negative 4. What would the coordinates of the turning point of a parabola y equals x squared minus 150 be? Well, hopefully you would notice that it would be going down 150, so it would be 0, negative 150 would be your turning point. Now let's see about the number added and subtracted from the input variable x before it is even squared. Yet again, the parabola y equals x squared is graphed below. Now consider y equals x plus 3 squared and y equals x minus 1 squared. Once again, I'm going to use two colors. I'm going to use y equals x plus 3 squared blue, and I'm going to use the other one going to be in pink for y equals x minus 1 squared. Go ahead and copy down all the table points at negative 5, 4, negative 4, 1, negative 3, 0, negative 2, 1, negative 1, 4, and I went ahead and plotted those. So go ahead and you can copy these tables down and graph those points. Let's take a look at what's going on in blue first. That is y equals x plus 3 squared. It says y is the horizontal shift counterintuitive. So why did it move the opposite way? Well, because we're squaring it after the fact. So we have to take a notice that This y equals x plus 3 squared, that's in blue here, it said plus 3. So you would think it would move to the right 3, but it doesn't. Because it's inside my parentheses, we're going to do the opposite. It's going to move to the left. And the pink one says negative 1. You would think we would move to the left 1, but we don't. It's the opposite. We move to the right 1. So it says state the coordinate pairs for each one of these. The coordinate pairs is 1, 2, 3, so it's negative 3, 0. And this one would be positive 1, 0. And to make sure that we notice that it's opposite. Notice that it's a positive 3 here, but inside my parentheses it's a negative 3. So make sure that we know that it's counterintuitive, which means it did the opposite. Now we're going to jump back to the front page for exercise number 2, putting it all together. Consider the basic quadratic function f of x equals x squared and the more complex quadratic function g of x equals x minus 2 squared minus 4. The graph of f of x equals 2 is shown on the grid already. Using your calculator to generate a table, sketch a graph of g. What I'm going to do is provide you a table and graph it. So go ahead and hit pause and try to calculate these on your own. Alright, well, I gave you the points, so go ahead and copy in the points. And now copy down the graph as well, plot those points. How would you need to shift the graph of f of x to get to the graph of g of x? So if I took this here, this f of x graph, what would I need to do? Well, I would have to pick that up, shift it to the right, and then down. So let's write that in there. I would shift it right 2, down 4, in order to make it look exactly and fit right on top of it. So what is the turning point of g of x? Where do you see the turning point in the function equations? So let's take a look at what my turning point is. My turning point is 2, negative 4. 2, negative 4. So I'm hoping that you notice that my 2 is coming from the opposite here. So this says negative 2 inside my parentheses. I know that it's my opposite, so it's positive 2. And my negative 4 is outside my parenthesis, so that goes to my y. One of the things that I want you to remember is that inside my parentheses means I'm going left and right, and it's always the opposite. Outside my parentheses means we're shifting up and down. Alright, let's take a moment and practice. What I'm going to do is I'm going to do the first one with you. Y equals x minus 8 squared plus 5. So hopefully you realize that inside my parentheses is moving left to right. So that means I'm going to move right 8, up 5. So what do you think that the vertex is going to be for that? It's going to be positive 8, comma, positive 5. Now let's take a look at this middle one. It has something new here, and it has a 5 out front. Is it a positive 5? It is. So that just means that my parabola is going to be a little narrower, okay, but it's still going to be opening upward. My vertex means it's going to go left 1, down 4. And it is going to be definitely narrower, and it's definitely going to have a vertex that is at the bottom. So my vertex is going to be negative 1, comma 4. And it should, if I drew my x and y axes, it will look like this. The third one has a negative 2. So that means it's going to be a little bit more narrow, okay, and it's going to flip upside down. The negative 3 means I'm going to go right 3, down 10. So right 3, down 10. So it's going to be a positive 3, negative 10 for my vertex. And don't forget, because it's upside down, or because that negative out front of the coefficient, if I drew my x and y axes, it definitely would look like that. So therefore it would be max. Don't forget my vocabulary words that this vertex is a minimum, this vertex is a maximum.